So in this video, we're going to continue with ratios and proportions, but relate them to chemistry. And so we've been doing balancing equations for a while, since grade 10. And those numbers actually do play an important role. We get to use these numbers, these coefficients in the front, to actually figure out how many particles or molecules react, and even to predict masses that will be produced in grams later on. But let's just go ahead and take a look at how we would do that. So let's write some ratio expressions that compare reactants. So in this reaction, there's two sodiums, 2Na, for every one Cl2. So what is this? Well, this is a 2 sodium to 1 chlorine ratio. It's a 2-to-1 ratio, in other words, 2-to-1. I just like to specify 2 of what to 1 of what. So that's a bracket there, bracket here. Write a ratio to compare Na and NaCl. So let's look at Na and NaCl. There's 2 NAs for every 2 NaCl. So this is a 2 Na to 2 NaCl ratio. And you can simplify that to simply 1 Na for every 1 NaCl. So essentially, if you had 1 Na, there'd be 1 NaCl. If you had 2 Na, there's 2 NaCl. If you had 3 Na, there's 3 NaCl. So you can just kind of use the same ratio like that because they're a 1-to-1 ratio. Write a ratio expression to compare Cl2 and NaCl. So Cl2, there's 1 Cl2 for every 2 NaCl that's produced. So that's a 1 Cl2 to 2 NaCl ratio. It's a 1-to-2 ratio, basically meaning that there's always going to be 2 times more NaCl than Cl2. So for example, if I had, let's say, and this is an aside here, let's say I had 2 Cl2s, then there'd be, well, 4 NaCl. So there's always 2 times more of it. It's in a 1-to-2 ratio all the time. So we can use the idea of these ratios here to solve problems like the one over here. If there's 8 NaCl produced, how many Cl2s must have reacted? Use proportions and ratios to solve this problem. So we're comparing our NaCl to our Cl2. So based on our equation, we know we get 1 Cl2 for every 2 NaCl. And in our situation here, let's have my ink dried out. Let me retry that. In our situation here, we want to figure out, well, okay, so suppose we had 8 NaCl, keep that at the bottom there. How many Cl2s would we have had? And so we can cross multiply. We can get that the number of Cl2s is equal to the 1 Cl2 in the original ratio times 8 NaCls over 2 NaCl. NaCls will cancel out because you have one numerator, one denominator, and you're left with Cl2. So you have 1 times 8 divided by 2, 4 Cl2 molecules if you had 8 NaCl. If you had 8 NaCl. So that there is one way you could use that. Now, let's say you had 8 NaCl molecules produced. How many Na could have reacted? So now we're comparing NaCl to Na. So normally, if we're comparing NaCl to Na, what was our ratio? It was a 1-to-1 ratio. So just by looking at it, you would know that they're the same. But just to show you that with some math here, we said we want to know how many NAs reacted. So we had 1 Na based on our ratio for every 1 NaCl. Now in our circumstance, we have 8 NaCl, and we want to know how many NAs we have. So we can just cross multiply, and we get the number of NAs is equal to 1 sodium times 8 NaCl over 1 NaCl there. Cross out NaCl, and so you just have 8 over 1 with Na left over, and so the x is 8 Na. But it's a 1-to-1 ratio, so if this is a quick multiple choice style question, since it's a 1-to-1 ratio for NaCl to Na, If you have 8 NaCl, you should also have 8 Na. So you can just spot it that way. You can do it quickly in your head. Once you understand ratios very well, you can move a lot quicker with it, and you know your answers will make sense. Let's try one more problem here. Let's do, oops, right over here. You have 16 sodiums. So let's say 16 sodiums reacted. How many Cl2s must have reacted? So now we're comparing our Na to Cl2 ratio. And I think we found that for Na to Cl2, it's 2-to-1 ratio. So we want to find out how many Cl2s we have. So when I look at my ratio here, I'm going to put the Cl2s on top. So I'm going to say there's one Cl2, and every time there's one Cl2, there's 2 NAs. Now, my actual situation that I have in my lab I'm doing, I said, you know what, I'm going to have 16 NAs. So then if I'm doing this lab, to keep the proportions, to keep these proportions and these ratios, I have to figure out how many Cl2s I need up here. Now, just by quickly looking at it, you basically realize that you have 2 times more NAs every single time. So if you have 2 Na, you have 1 Cl2. If you have 4 Na, you have 2 Cl2. So if I have 16, I should have 8 Cl2. I'm just basically dividing by 2. But let's just show you that with math here. We do our cross multiplication. Then we get 1. So we get x Cl2s. So the number of Cl2s is equal to 1 Cl2 times 16 Na over 2 NAs. You can cross the NAs out because they're numerator and denominator, same unit. And we get x is equal to 1 times 16 divided by 2, 8 Cl2 molecules must have reacted because it's a 2-to-1 ratio. We have, if you look at our equation up here, if we have 2, we have 1. So if I had 16 Na, I'd have half of that, I'd have 8 Cl2. So we maintain the same proportions in these chemical reactions. That's actually how they work.